Hello and welcome to this video on graphing quadratic functions of the form f of x equals x squared plus k, or y. Remember, f of x is just the representation of the output y coordinates. You could say y equals x squared plus k, where k is a real number. All right. So in this video I'm going to first begin by discussing something called function transformations or graph transformations, and that's where you're going to take a basic graph, a graph of some function, and move it around somehow on the coordinate plane by just a simple tweak to the equation. And the particular transformation I'm going to be talking about in this video is vertical translations or vertical shifts, right? Just moving the graph up and down on the coordinate plane without actually changing the shape of the graph. All right, so let's begin. So like I said on my first page here, I'm going to be discussing function transformations, and just one particular kind in this video, vertical translations, aka also known as vertical shifts. Right. So suppose we are given the graph of a function of, say, y equals, and then some f of x. Right, so this could be y equals x squared, y equals 2x plus 1, y equals 3x cubed minus 5x squared plus 7. Right, just y equals some expression that depends on x. So inputs x, outputs y. Well, what's going to happen is, so here's say I have the coordinate plane. I'm just going to draw a very rough little xy coordinate plane over here. So suppose this is the xy plane, and I have the graph of the function f, and I'm just going to make it a little simple curl, something like this. Say there's the graph of f of x, y equals f of x. All right, just a little thing like that. Maybe it goes off to the ends forever. A little smiley. We can move this picture around, and in this video I'm just going to talk about moving it up and down. We can move this picture up and down by just a very simple change to this expression, a very simple change to the equation, and it's simply by adding a number. So if we're given the graph of, say, y equals x squared, y equals whatever, y equals some expression dependent on x, some f of x, then the graph of y equals f of x, so I leave the expression I had in the beginning alone, but then after that just make this one little change. I take my original equation, and then I just simply, to the side with the expression with x in it, I simply add a number. Okay, and this number k is just going to be a real number, right? So plus 5 or plus 7 or minus 4, plus negative 4, and so on. The addition of this k will do one of the following things. One, the graph of y equals f of x plus k, if that k is a positive number, right? If k is greater than 0, then the graph of y equals f of x plus k will be the graph of the original moved up k units. So if k is positive, the original graph is moved, or translated or shifted, is moved up k units. All right. So I'm going to do this in first one in red. So I would have the same exact shape, but then just move everything up k units if k is positive, right? So again, this isn't perfect, but have the exact same shape, but just move everything up k units. And again, that's if k is positive. Right. Now the only other case we're going to concern ourselves with is if k is negative, right? Because if k is 0, that's meaningless, right? Adding 0, well, then you just have the original equation, you have the original graph, it doesn't move anywhere. So then if k is less than 0, then the original graph is moved down, or shifted or translated down. Now I'm going to say the absolute value of k units, just to make it positive, because if k is negative, the absolute value of k would make it positive, just to talk about distance, and usually distance is a non-negative thing. So again, we'd keep the same shape, right? Here's my original graph, y equals f of x, and I'd keep the exact same shape. Right, that's that little smiley and all that. It's not perfect. And then it would get shifted down, the absolute value of k units. Right, and these would be the graphs of y equals f of x plus k, right, or y equals f of x plus k, right. So it's just you take your original equation and simply leave it the way it is, add some number after it, add some number to the side with the input variable, and it'll move your graph up and down. And if you want to talk about what you're actually doing to the coordinates of the points, right, you could also say that you're simply adding k, right, whatever k is, to all the y coordinates of the original graph, right, all the outputs. And that will move your picture up and down. Okay? So that's what I'm going to be doing for the rest of this video, is we're going to look at some quadratic functions, right? Where we're going to start off with the most basic quadratic function there is, y equals x squared, and then change it, right? Move the graph of y equals x squared up or down, depending on what number gets added to it. Okay? So I have some graph paper for these next examples. Right, so I'll come back to this page maybe later. So my first example, just got a couple. This is a pretty simple concept. I feel most people tend to understand vertical shifts pretty easily. So here I'm asked to, for both the examples I have, I'm asked to use the graph of y equals x squared to graph the quadratic function f of x equals x squared plus 5. Right? And I'm also asked to label 3 points on the graph, right? Show at least 3 points on the graph. All right. So before I do that, let's actually make the graph of y equals x squared, and I'll do that in a red color. So first, let's graph y equals x squared. I'm going to make a little table, as I've done before, right? My inputs for x, the outputs are how they're calculated, and what points I'd be plotting. All right, and if you've seen me put up graphs before, videos where I've done graphs before, this is typically how I do them. So inputs for x, Now, since there's no restriction on the domain here, right? This is just x squared. You can plug in anything for x. I like to plug in these 5 values centered around 0. Alright, so I'll plug in -2 to 2, and then when x is -2, y equals 4, and then when x is -1, y equals +1, right? When y is 0, when x is 0, when x is 1, y is 1, when x is 2, y is 4. And the ordered pairs, the points I'd be plotting, -2, 4, -1, 1, the origin 0, 0, 1, 1, and 2, 4. Alright, so I'll plot those, and again, you'll see I've put up a video in the past where I've graphed this before, and this is one of those basic parabolas, right? This is the most basic quadratic function there is, and the graph is one of those U-shaped looking things called a parabola. Alright, so back on my coordinate plane, I'm going to plot these 5 points and draw in the rest for y equals x squared. So I'm going to have each, my x-axis is horizontal output, y-axis is vertical, and I have each square representing 1 unit, right, in both directions. So -2 for the x, +4 for the y, and there's one location, 1 point. Then -1, +1, another location on this graph. The origin, right, 0, 0. Then 1, 1, another location, and then +2, 4, 2 for x, 4 for y. Alright, so remember, this is one of those U-shaped graphs, parabola. Looks like this. Alright. And it just keeps going up, forever. It keeps increasing as you move to the right. And same thing going this way. Alright, it just keeps getting larger and larger as you go to the left as well. Alright, it's one of these U-shaped graphs, little arrows on the ends to indicate it's going up forever. There's the graph of y equals x squared. Right. Okay. Now what we're asked to graph is, f of x equals x squared plus 5. Now if you recall from the sheet I put up earlier, the expression with x that I have is the exact same thing, right? I'm starting off with y equals x squared. Well, there's x squared there. Okay, so I'm starting off with the exact same expression to calculate my output, but then adding 5. Right? So that's like this f of x plus k, my original expression, and then plus some number. Well, notice it's the original expression, right, x squared, but then plus 5. Right, a positive number is being added. So according to what I wrote on the last page, that's a positive number being added. Then the original graph will be moved up 5 units, right? K is 5 here. Or in other words, I'm going to be adding 5 to all the y coordinates. And you could also see that in a table, right? I like making tables when I make graphs, as you probably should anyway, right? But I have f of x equals, x squared plus 5. I'm going to do this in a different color, like a green here. I'm just going to add to this chart. So over here we're looking at, f of x equals x squared plus 5. And I'm just going to plug in the same values for x, right? So this column here, still using these x's, okay, -2 to 2. But now over here I'll calculate the outputs for this new function, f of x equals x squared plus 5. And do you see when I plug in -2, right, you get the original -2 squared, which is 4, but then you're adding 5 to that. Right, so like I said earlier, we're going to be just adding 5 to all these y coordinates. So 4 plus 5, 9, 1 plus 5, 6, 0 plus 5, 5, 1 plus 5, 6, and 4 plus 5, 9. And then the ordered pairs I'd be plotting, right, the x comma f of x, or the x comma y, right? You can always replace f of x with y, and it means the same thing, the outputs. The ordered pair I'll be plotting from this first row is, -2 for the input, 9 for the output. And then -1 input, 6 output. Then 0 input, 5 output. 1 input, 6 output. 2 input, 9 output. And hopefully you can see after I plot these points that we will indeed have a graph that's just shifted up 5 units. Alright, so I'm going to mark off these locations on my coordinate plane here. So the first one, -2, 9. Well, again, remember, it was -2, 4 originally, but all I'm doing is adding 5, that plus 5 afterwards to the y coordinate, right? So from 4 to 9. So mark off that location. There's -2, 9. -1, 6, right? It was originally -1, 1, but then the addition of 5 afterwards just bumps that up 5 units to -1, 6. Then 0, 5, right? 0, 5, which again, the original had 0, 0, but the addition of 5 after that original expression just bumps it up to 0, 5. And then 1, 6, and 2, 9. Okay, so I marked off all those locations. I'll make the graph. And you'll see it's the same shape. Okay, the shape does not change. It's the exact same parabola, just shifted up 5 units. Right, and I'll make that little mark here. This was up 5 units. Alright, we had a transformation go on. And this is y equals, x squared plus 5. Right. Great. So, you can always make a table, right? Make a table, plot enough points to where you see a pattern forming, and then fill in the rest of that pattern just like you do with any graph. You can always do that. But if you recognize, hey, I know the graph of y equals x squared, so then the graph of y equals, or f of x equals x squared plus 5 with it's just the same as the graph of y equals x squared, but then up 5 units, right? You just add 5 to all the y coordinates. Okay. So I have one last example, right? Again, this vertical shift in translation I don't think is too bad. So I'm asked to do the same thing here. You use the graph of y equals x squared, so I'm going to start with this again. And then, to graph the quadratic function f of x equals x squared minus 2. And then, show some points. And, I showed 5 points in the last one. Technically, I should have labeled them, but you could see them from my table. Alright, so as before, I'm going to first graph y equals x squared. Right, so bear with me here. This is going to be the same 5 points, right, from this table. Right, there's y equals x squared. I'm going to put the same 5 points down. So -2 on the x, 4 on the y. That location. -1, 1. 0, 0. +1, 1. And 2, 4. And draw in that parabola again. Here's y equals x squared. All right. So that's the original that I'm asked to start with. And then you see this equation here? This is like y equals, or again, f of x equals x squared. Right? There's the original expression again, x squared. But then a number is added to it, right? You're adding -2. So the value of k here is negative. And remember from my first page, if I take my original expression from the original function and just simply add a negative number, right? K is negative, then the graph moves down, the absolute value of K units. So just say down 2, right? If I'm adding -2 to the original, it's just going to move the original graph down 2. Alright, and let's actually, I'm going to just keep this table up here. We'll add to it. Alright, so now we're looking at this. So I'm going to make a little table down here for f of x equals x squared minus 2. Alright, and I'm not going to, I got this, I don't have my x's in line up there, so I'm going to write the same x's down here from -2 to 2, and then how they're calculated, right? How the output's calculated, right? What's f of x, and then the ordered pairs that I'd be plotting, the points that I'd be plotting, input x, output f of x, or output y. Alright, so hopefully you can see that all I'm going to be doing is, for the y coordinates of this new graph, is taking the y coordinates of the original and subtracting 2. Alright, so look at this. When x is -2, you got your x squared, which is 4. -2 squared is 4. So that y coordinate up here, but then -2. So 4 minus 2, 2. So the ordered pair is -2, 2. Then again, all I'm doing is taking these original y coordinates from the y equals x squared and then subtracting 2 from them. So 1 minus 2, -1. 0 minus 2, -2. 1 minus 2, -1 again. 4 minus 2, +2. And then the ordered pairs I'd be plotting, -1, -1, 0, -2, 1, -1, and 2, 2. Right. And again, all we're going to see is that the graph of this new function, right, y equals x squared minus 2, is the graph of the original, shifted down 2 units. Right. So let's plot those points. -2, 2. There's that location. -1, -1. 0, -2 on the y-axis there. 1, -1, and 2, 2. And you see the shape doesn't change. The shape does not change. All that changed is the location of the points. Okay, so these should not be touching, right? This red graph here moved downward 2 units. All that happened was it got shoved down 2 units. Right, that absolute value of k, where here k is -2. Great, and there you go. There's the graph of y equals, or again f of x equals x squared minus 2, with a few points, 5 points on there that are marked, or I got the 5 points in the table over there. Very simple. All right. So if you have, this isn't just for x squared. All right, this doesn't work for just x squared. You take any function, y equals 5x, y equals x cubed, y equals 2x plus the square root of x, whatever. You take any function, look at its graph, and then just leave the expression the way it is, like x squared here, and then add some number after it. Add some number to it, and all that's going to do to the graph is move the graph up and down. Alright, up if it's a positive number, down if it's a negative number. Hopefully very simple concept, very easy to see. And that's all I've got for you here. Alright. And as I like to say at the end of these videos, please do the best you can to try and learn the material on your own before you go looking for help. I have found over the years that people who take the time and the effort to learn something on their own tend to remember that material better and also remember it for longer and are more proud of themselves, boosting confidence. So obviously read the material, right? Read through the author's examples. Perhaps even try to work out the solutions to the author's examples before you see how the author did it, and then compare your work with the author's and see if you can learn from some mistakes there. Obviously do tons of exercises, practice problems. It's the only way to get better. Look for solutions to those if they're made available to you, so you can check your progress, see how you're doing. And don't just give up on a problem after 1 or 2 attempts. Don't give up so easily. Very often in mathematics there are several approaches that'll work for any particular problem. So, if after several attempts at a problem you're still having trouble, I would suggest to you that you actually go back and read the material again, maybe even a third time, more slowly, more deliberately. Take good notes. Because if you've been working on problems as you should, you probably have a better idea as to what the author is expecting of you, what the author wants from you. You'll have a better idea as to what the author finds important about the material. So when you go back and read again, you'll know better what to look out for in that reading. You'll know what's considered most important by the author. And maybe even catch a few things that you didn't the first time that might make working on the problems that much easier. Alright. But if after several read-throughs of the material and several attempts at the problems, you're still having trouble, still having a hard time, it is not a sign of weakness whatsoever to go looking for help. That is what other people are there for, to help you. Alright, so ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's tons of it out there. Look for videos online, right? There's tons of those too. Videos like this one, or plenty of other ones out there better than this one. I assure you they're out there, and they're easy to find. But just keep at it. Stay persistent. Keep practicing. Don't give up. And above all, and I think this is the hardest thing for most people, stay positive. Right? Believe in yourself. Believe in your abilities, even through your struggles and failures and mistakes. Because it's in those moments of struggle and failure and frustration that you have the opportunity to learn the most, and learn the most deeply. If you can persevere and work through your frustrations and actually learn how to fix your mistakes, you'll remember that material far longer and far better than a person who got it right the first time and then never gave it a second thought. It'll stick with you more. It'll stick with you longer if you had to struggle through it and learn through your failures. So, stay persistent, keep practicing, stay positive, and don't give up. And I know you'll get it. All right, and thank you very much for watching.